Hi everyone. Today we'll discuss one more problem on sequences and infinite series. So test for the convergence of the series. This problem I have already solved. I will show you by another method this problem. So un equal to n plus 1 whole to the power of n into x to the power of n by x to the power of n into n. Okay. Now applying Cauchy root test. What the Cauchy root test says, wherever un is there, write 1 by n. So un to the power of 1 by n, this is 1 by n, this is 1 by n. So un whole to the power of 1 by n equal to this getting cancels. So you are left with n plus 1. This n getting cancels, n plus 1, x to the power of this getting cancelled. So only x. This is root n. Now this is un whole to the power of 1 by n equal to, taking n common, it will be 1 plus 1 by n into x into root n. So what the Cauchy root test says is sigma un is a positive term series, then limit n tends to infinity, un whole to the power of 1 by n equal to L. If L is less than 1, convergent. If less is greater than 1, divergent. If L equal to 1, test fails. Test fails. So now applying the limit. Applying the limit n tends to infinity. Applying the limit n tends to infinity. As n tends to infinity, 1 by n tends to 0. So this is 1. X, limit n tends to infinity, nth root of n is 1. Please make a note. So this is equal to x. Therefore, x is less than 1, convergent. X is greater than 1, divergent. X equal to 1, test fails. X equal to 1, test fails. That's it. So it is a conditional. Answer is, how can you say by this? We can say by Cauchy root test. So Cauchy root test fails when x equal to 1. Now test for when x equal to 1. What will happen when x equal to 1? So what is our un? Un is x n plus 1 whole to the power of n, x to the power of n by n plus 1. So we says when x equal to 1 means this is gone, n plus 1 whole to the power of n, whole to the power of n into n to the power of n into n. What we are doing, n plus 1 by n whole to the power of n common, 1 by n also. If you take n common, it will become 1 plus 1 by n whole to n. N common and cancelled. N plus 1 by n. If you take n common from the numerator, 1 plus 1 by n. Denominator, n is there. This getting cancelled. So 1 plus. Now, un equal to this thing is. So in the last type, in another, if you see another video on this thing, I use the definition. From the definition, I prove the series behavior of the series. Okay. Now we have to go for the. Some teacher says, no, if why you want to go for the definition? If you have the test, so many tests are there. Go apply the test. Okay. Okay. Let's go with that. So let Vn equal to 1 by n. Let Vn equal to 1 by n. Vn equal to 1 by n. Summation Vn equal to summation 1 by n. Now comparing with the P series, 1 by n to the power of P. What is say P equal to 1, less than or equal to 1, the series is convergent. When P equal to 1, series is Divergent. Sorry, not convergent, divergent. How can you say? By P series. Now, this part is divergent. Now, I want to apply the limit comparison test. Limit n tends to infinity, un by vn. Limit n tends to infinity, un by un. This we are doing for the finiteness. So 1 plus 1 by n whole to the power of n into 1 by n by 1 by n. Getting cancelled. This is equal to E. This is equal to E. E not equal to 0. Finite and non-zero. Non-zero. Therefore, summation un is divergent by comparison test. By comparison test. Let me write down comparison test. The series is divergent by comparison test. Therefore, un is divergent by comparison. That's it, sir. Those who are watching, sir and ma'ams. So this appeared in the Osmania Engineering June 15 long question problem. So first, for the long question problems, you can't leave the problem test fails. Why test fails? Test fails means you have to apply another test. So therefore, we applied the another test, that is limit comparison test. In another problem, I have done by the basic definition. So this is the series is divergent by P series. Then finiteness, after finiteness, therefore by the limit comparison test, what it says, let me write down that statement. By limit comparison test, what it says, sigma un and vn both converges or diverges together. That means if you see the finiteness, it is divergent. Then if it is finite, un is also divergent. Thanks for watching. Please do subscribe my channel and share with your friends.